Translation. This is probably the easiest of all the transformations. See what I did there? Here's a translation. This shape is translated to here. Really, it's really just a slide, isn't it? This corner goes to here, this corner goes to there, and that corner moves across to there. Every corner has moved 3 along and 1 up. Why the corners? Because just like every other transformation, if you move the corners correctly, the shape will follow. Don't bother about lines, just look at the corners. Every part of the shape moves the same way, and the shape is not altered by the translation. Move the corners and the shape will follow. That's my message regarding transformations generally, but particularly translations. Here's the same translation. Let's look at it in more detail. A translation can be described by a column vector in the form 3, 1, say. Well, that's 3 along here and 1 up. The top of the column is the X move and the bottom is Y. So maybe think of it like that, where this is the X movement, a movement along the X axis, and this is Y, the movement up the Y axis. The way I remember this is to imagine you have an ordinary coordinate, which we know is X, Y, and you rotate it to form a column vector, X, Y. The X will be on the top. Now, that's worth remembering. Because a translation vector is the same as a column vector, isn't it? They can be added. So if P equals 2 minus 2 and Q equals 5, 3, for example, we can add them. The translation vector P plus Q, 2 and 5 is 7, minus 2 and 3 is 1. 7, 1. What's this like when we show it on the graph? Well, let's follow just one point. I think once we get the point right, we can draw the rest of the shape. P is 2 minus 2, so that's 2 along and 2 down, so it's here, and we can draw the shape B there. Let's call it B. And Q is 5 along and 3 up. 1, 2, 3, 4, 5, and 3 up. 1, 2, 3, so that's there. And again, we can draw the shape. Now, this is the result of 2 translations. However, we can have one translation, just this big one, which is 1, 2, 3, 4, 5, 6, 7, 1. And as you can see, 7, 1 is the addition of these 2 column vectors. So, I hope that's clarified the use of column vectors for multiple translations. So, here is a chance for you to show your skills. Oh, it's the addition of column vectors. That's useful. So we are forming this translation vector. So I just take P, which is 3 minus 5, and I add 2Q plus 2, 1.5, 2. I'll make it easy. I'm not going to do it in one go. I'm just going to work this one out. 3 minus 5 plus 2 times 1.5, 3, 4. Thank you very much. And now this is a simple addition. 6 on the top and minus 1 on the bottom. So we have 6 minus 1. So draw and label B. Okay, we're going to draw and label B. Let's take a point. And it's 6 minus 1, so that's 6 across and 1 down. So that's there. And we'll take another point. 6 along, 1 down. That's there. Great. Now, we can see this part of the shape. We've got 1 going across and 2 down, so I can draw that in. And here I've got sliding along 2 and then 1 up. So I'll have slide along 2 and 1 up. But we're getting the shape. I think from here we can fill in the rest of the shape without drawing any more points and call it B. Pretty pleased with that. How would we check this? Well, this has to be checked, obviously. We have to check the calculation. And then make sure that we've drawn 6 minus 1. I know we've said it, 6 minus 1, yes. The more points that you show on your chart, then the more likely you are to be accurate. But there's a limit to that. You don't have to draw every corner. And I think 2 corners is enough for this. We've taken something that was a little bit tricky and we hopefully made it easy. If you've liked this video, or even if you haven't, why not subscribe? There's plenty more to come. See you soon.